Hello there, sir. Exercise 2C for Year 12 mathematicians, looking at the discrete uniform distribution. And this sounds a bit easy, to be honest, when you look at it first of all. For instance, one example of the discrete uniform distribution is what happens when you roll a die. And this diagram up here is meant to show this. Obviously, you could get lots of different outcomes. When I say lots, well, there's 6 different outcomes. And those 6 different outcomes are all equally likely, and therefore they all have a probability as a sixth. And notice I've just drawn this. I've gone up and I've drawn at the top of a line the probability of this. Is like one way to draw a probability, almost like a line graph. But each line is the same height because they've all got the same probability. So you know, they are all of the same height, as that blue line is meant to try to show. But the actual graph is really basic, really. I'm going to do something as well during the exercises, and I think this is quite useful. So just a reminder of in our starter of nth terms. You should recall that, for instance, these go up in 4s each time. Clearly see that. So my formula for this is 4n. Now 4n, 4 times table really is 4, 8, 12, and you notice I'm adding 2 to go from there up to the actual numbers I want. So my nth term is 4n plus 2. So can you try and find me the nth term for the other 3, please? Pause the video and see what you can get. Look, I'm hoping you have found these. These go up in 2, so these are 2n. But 2n goes 2, 4, etc. So I'm going to reckon that must be 2n minus 1. These go down in 3s. Now, one way of writing that is minus 3n. And you have to write out the negative 3 times table. And you say to yourself, what do I do to negative 12 to get up to 3? What do I do? It's the same every time. I have to add 15. So that's the answer, but most people would prefer to write it as 15 minus 3n. And what's this one? This goes up in 1s, so it's just n. Could write 1n, I suppose. And to that 1 times table you add 3, but again I much prefer n plus 3. So have I got those answers? Yeah, notice I've written it in un as like a nth term kind of formula. So they're the sequences. We'll use those later. The discrete uniform distribution then has the same probabilities for all its possible values. That's why it's called a uniform. Uniform as in uniformity. They're all the same. These values always start at 1 and go up to n. By that I mean, for instance, the example I had just now was 1, 2, 3, 4, 5, 6. Now your numbers might not do that. They might start at 10 and go up in 2s. And there might only be, I don't know, 4 values that are possible. Now, this would not in its own right be a discrete uniform distribution, but perhaps we can make it into one using like the tricks I was showing you before. Now there are 3 formulas that we are given in the OCR Further Maths formula book, and this is for A-level and AS. Basically it tells you that if you've got a uniform distribution over n things, notice where you write it. You write x is uniform. And in the dice example, I'd write 6 because there are 6 possible outcomes. It won't therefore surprise you that the probability, we found the probability for ours, was a 6th. Well, of course it is, it's a dice, we all know it's a 6th. But therefore, no surprise for you if it's a more general one that goes up to n, the probability is 1 over n. And we've got 2 formulae here, and one is for the mean, e of x, and it says it's n plus 1 over 2. I suggest you write these down, even though they're in the formula book. And the variance is a little bit more complicated formula, a 12th of n squared minus 1. And don't be surprised if you are asked to prove these 2 results. This one's obvious, but you might need to prove these. So, and there you are. In fact, the very next question, it says, show that e of x is this. And now this, I suppose, we're going to rely on our work that we did last time. And last time we basically were finding with discrete random variables, and we were looking at those tables. If you remember, we had x and we had p and we had various values, and I remember basically saying if you times one by the other you get e of x. So I suppose really that's what we're going to do here. e of x for us would be, well, it says we're always going to start at 1, 2, 3, and it goes up to n. And each probability is going to be 1 over n, 1 over n, 1 over n. It's a bit boring, this. So it will be 1 times 1 over n plus 2 times 1 over n plus dot, 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 dot. And eventually, I'll get up to the last one, which will be n times 1 over n. Well, one thing I can do is I can take out 1 over n as a common factor. And you'll notice if I do that, I get 1 plus 2 plus 3 all the way up to n. And I suppose if I can work out what this is, then I've got my question done. Now luckily these are called the triangular numbers. These are triangular numbers, and there's a formula that I want you to know for the triangular numbers. It's basically, if you add up all the triangular numbers, you get a half of n. It's usually n plus 1. I say usually because I've just got to make sure I've done it right. So let's take the first 4. 1, 2, 3, 4. If you add those together, you get 10 when I add them. Notice my formula says a half of a number of numbers, so a half of 4 times by, and then it says 4 plus 1, times by 5. And 4 5s are 20, a half of 20 is 10, yeah, it works. So this formula for triangular numbers works, so I'm just now going to write 1 over n, and rather than 1 plus 2 plus 3 plus dot 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 up to n, I'm going to write times by a half of n plus 1. And that's quite nice actually, because the n and n cancel. So this can be written as n plus 1 over 2. Which yes, it is. That's the formula they wanted me to prove. To get variance of x, you should remember the formula that I have to first of all do e of x squared, and then I take away e of x, and that's how I find the variance of x. So the very first job, presumably, is to find e of x squared. Well, that's 1 times by, well, 1 squared times by 1 over n, plus 2 squared times 1 over n, plus 3 squared times 1 over n. And it carries on until you get up to n squared times 1 over n. And again, you use the same trick. You take out 1 over n squared, and you get 1 squared plus 1 over n, by the way, 2 squared plus 3 squared, all the way up to n squared. Now this is a less obvious formula, but it is a formula you get told in the formula book. So the formula for this is, I'll write it up here. So posh way of writing this is the sum of all the values squared from 1 to n is n plus 1. 2n plus 1 over 6. Now don't worry about where this formula's come from. This is one that eventually you will do in further maths, in the pure side of further maths. For right now we can just use it. So it becomes 1 over n times by, what does it say? It says n plus 1, 2n plus 1 over 6. And that seems right. So this becomes, well, notice the n's cancel again, and I get n plus 1, oops, n plus 1, 2n plus 1 over 6. Notice, by the way, I now have to do a little bit of work because I've got to do the variance of x, and as I've said, it's e of x squared minus e of x squared. Missed a squared the first time. So that's e of x squared, which is this thing, n plus 1, 2n plus 1 over 6. Minus m plus 1 over 2, but it's got to be squared. So squared and over 4 when I do that. So if I try to do this, well, probably the best thing is to take out a common factor of a 12th, because 6 and 4 both go into 12. And also, I think I can take m plus 1 out as a common factor. Now, m plus 1 over 12 is a bit weird. What do I do to that to make it over 6 again? Well, it's 2 lots of 2m plus 1, because that's already gone. I've got that, but mine's over 6, and I've made it now over 12, so I've got to double it. Now this one's over 4, so this one's minus 3 lots of and I've got an n plus 1 squared, but I've only taken n plus 1 out. I think I need an n plus 1. So if I just tidy this up, I get n plus 1 over 12. What's that bracket give me? It gives me 4n plus 2 minus 3n, because there's a minus on both of them, minus 3. So I think that's n plus 1. I got an n minus 1 over 12. Ah, that's what I wanted, because if you multiply that out, you get n squared minus 1 over 12. Check it if you don't believe me. So this next one is one that is not such an obvious one. So the actual question I want to do is I want to find the expectation and the variance of a bunch of numbers, the odd numbers, between 20 and 30. That's what this is actually up here all about. Now to do it, I just want to take a step backwards. So I've got look at these odd numbers. I want the nth term. But they go up in 2s, so it's 2n. But what do? I think I have to, I have to add 19 to them to get them. That's what my nth term is. Now I know that. It says y can take any odd value between 20 and 30. Now e of y, so I suppose really what I'm saying is y equals 2n plus 19. That's what it's hinting at. And my numbers, of course, are not a uniform distribution. N, or x I could write, probably better, is uniform distributed of 1, 2, 3, 4, 5, and I've got 5 of them. Now, those 5 uniform numbers, then I know that e of x would be equal to, well, it's simply what I expect. And this is what I saw just now in my formula. It says n plus 1 over 2. So I've got 5, so it's 5 plus 1 over 2, and that's equal to 3. And my var of x, well, I had a formula for that as well. It's n squared minus 1 over 12. So it's 5 squared minus 1 over 12, which I think is 25 or 24 over 12, which is 2. So I've got these two answers. I perhaps should have written my y as y equals 2x add 19, since I ended up writing x for my odd numbers. Now notice then, if I want to work out what e of y is, now this is coming back to what we saw last time. E of y is really e of 2x plus 19. And as I saw last lesson, what you can do is simply say, well, I know what e of x is. It's 3. So e of 2x will be 2 times 3. Oh, it's e of 2x plus 19, so I add 19 on as well. That's 25. Now look at the numbers. I reckon, on average, I'm going to get, if I pick one out of those at random, I'm going to get 25. That's no great shock. Now the variance of y, we've got to be a bit more careful with, as we saw last time. So the variance of y is really the variance of 2x plus 19. And one thing we should remember, if you add 19 to a number, the variance won't change. No difference at all. But the 2x will. And you should recall that we do 2 squared times whatever the variance of x was. What was it? It was 2. So lots of 2's flying around there, but I reckon my answer is 8. And you can't quite see it at the bottom, it's just slipped off the bottom, but it does say 8, so yes. Variance of e of y is 25 as well, and it was 2m plus 19. So yeah, that's all worked out quite nicely. With exercise 2c then, that's what we'll do in class. It just builds on more of what we've seen before in terms of expectation and variance. And I suppose what we're looking at doing is also introducing more and more new distributions. So in maths we've already seen the binomial distribution and the normal distribution, and this is what seems to be quite an easy one, the discrete uniform distribution. But there's more to come. There's lots more to come. So we'll have a look at those in due course.